Alright, so today we're going to start on our unit of energy. So it's an introduction to energy unit. Okay. Now we did a lot of energy in grade 9 science. Right? We already know that Canada is a very large user and production of energy. Right? We use it for things like transportation, heating, cooling, industrial productions like factories, leisure, things like that. And there's lots of forms that we use, right? Wind power, fossil fuels, nuclear power. Right? We're not going to go over all the pros and cons of each, but there are pros and cons of each, as we talked about in grade 9. Again, a quick review of grade 9, but heat transfers, like there are 3 different methods to actually transfer thermal energy from one object to another. So if you look at this example here you have fire, right, and that's transferring heat to the metal pot through radiation. The metal pot heats up and is in contact with the water, and so that's transferring heat through conduction, meaning through contact. And of course the water is undergoing convection currents where the hot water rises and pushes the cool water down, and that's heating the water through convection. Right? So that's just a quick review of grade 9. Today we're going to look at energy more quantitatively. So first, how do we measure energy? Well, the SI unit for energy is joules. Okay, there's lots of energy units that you've probably heard of. Most common one is probably calories when you go look at how many calories there are on a chocolate bar or something. But the SI unit is joules, and 1 joule is equivalent to a newton times a meter. That sounds like exactly the same units as torque, but it's not. Remember the big difference with torque was a vector, even though we never actually went deep into its directional properties. Torque is a vector. Energy is a scalar quantity. Right? So it does not have a directional property, only a magnitude. And if you remember the definition of a newton is a kilogram meters per second squared. Multiply that by a meter and you get your definition for a joule as a kilogram meters squared per second squared. Okay. So moving on, let's just go over all the different types of energy. You can have electrical energy. Right? If you plug something in, you have electrical energy. You have thermal energy. Right? So maybe you plug in a stove and the stove starts taking it up. So then you have thermal energy causing the water to boil so you can cook some pasta. Radiant energy, meaning from like electromagnetic radiation. So the sun provides radiant energy. You have nuclear energy from, say, nuclear fusion or fission in power plants or in the sun's interior. Okay. You have elastic potential energy. So you take an elastic band, you stretch it. Okay? That has energy. You have gravitational potential energy. So if you lift something up inside of a gravitational field, it has some energy. Kinetic energy, that's the energy of motion. So if you have something moving, it has energy. There's so many different forms. Chemical potential energy, so a firework has chemical potential energy. Okay, and then you launch it, and now it has kinetic as it's moving, and then it explodes, and you get light, which would be radiant energy. You get sound energy. Right? So energy comes in so many different forms, and that's really the hard thing about energy. If you're trying to look at a situation and quantify the entire situation, there can be so many forms of energy, and they can be transforming from one form to another. So let's just look at some examples. Examples are the best way to try and understand energy. So in our first example, so this is our handout. So I listed a whole bunch of different energies here. Okay. Our first example says, name at least one form of energy associated with each object in bold. So I'll go over 1 or 2, and then I'll leave the rest up to you. So first of all, I'll bonfire. So a fire, you might want to think, okay, radiant energy, right? It's giving off light. But of course, a fire is also hot, so you might also say thermal energy, right? There's lots of different types, right? Even if you want to have that crackling sound that I love so much when a fire, you can say sound energy, okay? A baseball smashes a window, so a baseball is moving, so you can say it can have kinetic energy. Right? Energy can also cause things to deform or break, so that's the window being smashed. So I'm going to pause there, and we're going to just discuss these other ones. Right? So a solar collector collects light, which would be radiant energy. Okay, and then it also changes that into electrical energy, and you can heat water with it, which would then be thermal energy, lots of types. A stretched rubber band, that would be elastic potential energy. And siren of an ambulance, so that's emitting light, so you can say radiant, but it's also emitting sound, so you can say sound as well. There's so many different types, I'm not going to write all of them. Okay, but we're just going to be identifying different types. Next thing that we're going to do is look at how energy can transform from one form to another. And I've kind of been talking about this with my examples, but energies can transform from one form to another. Later we'll talk about how all energy is also conserved, meaning you can't gain or lose energy. It's only transformed from one form to another. So here's an example. We have a microwave oven. So inside of a microwave oven, you plug it in, you start with electrical energy. Then it starts to emit microwaves. Microwaves is electromagnetic radiation, so that's radiant energy. And that radiant energy cooks the food that's in the microwave, right? It heats up all the water molecules. That is now thermal energy. And so we have energy being transferred from one to another to another. Okay, so we're going to go over some energy transformations on our handout. Okay. Before we start with energy transformations, I just wanted to go over this diagram. This is called an energy stores diagram. What it does is it just shows an estimated amount of energy before and after a transfer. Okay, so in this case, right, we start with electrical energy, and let's say you have a flashlight. So you put batteries in a flashlight, and you turn the flashlight on. You're going to use some of that electrical energy to produce light, but not all of it. Right? You still have electrical energy remaining. Okay, and the number I chose here, the number of dots, really is arbitrary. It doesn't matter. I could have chose 6 dots, 10 dots. The point that I want to make here is that the total number of dots before that transfer and after that transfer should always be the same. This is sort of hinting at energy conservation, which I'll talk more about in another lesson. Okay, so some of the important things to understand about energy. Okay, it can be stored. Okay, for example, if I lift something up, my water bottle, if I lift up my water bottle, right now it has stored energy. In this case, we call it gravitational potential, but it's stored because I can easily let go, and the water bottle, you can see that stored energy now changing into motion, which is kinetic energy. Right? Energy can be transferred from one to another, just as with my water bottle. And energy is transferred when work is done. So we'll talk more about work later, but a force is required to do work. So if you push something, you can get it moving. So you can give it energy. Or friction can take it away. It's another force. And all energy, right, regardless of its store, mechanism, or transfer, is energy. All right? Let's go over some examples of energy transfers. Battery-powered portable flashlight. Alright, it's kind of like in the example I just had, but let's just start with, some people like to say we'll start with chemical, which is fine. Right? You have chemical energy, right? Batteries are made up of chemicals, and so before you actually hook them up to a circuit, this is chemical energy. And, but we'll just say we'll start with a bit of chemical, which then would get transferred into electrical. I'll just put 5 here. Can get it transferred into electrical. So let's say we transfer 3 over to electrical, but we still have some chemical left over. And then that electrical, right, can be transferred into maybe thermal. Right? If you're just using an incandescent light bulb, those ones get pretty hot. So maybe a lot of it gets transferred into thermal. And then you'll get light, which is radiant. So thermal, radiant. Okay? And you still have this chemical over here left over, which can later be further transformed into electrical. Okay? Again, the number of dots I'm choosing really is arbitrary. The important thing is when you transfer, you don't lose or gain any dots, right? Because that can't happen. All right, next example, we have an electric drill with a rechargeable battery. All right, again, you can start with chemical, but I'm just going to start with electrical. Let's just say we already have that electrical energy. Here, I'll give it 6 this time. We already have that electrical energy, and when we turn on our drill, we're going to get motion, right? The drill is going to spin, and that's called kinetic energy. And a lot of it's going to be kinetic energy. So let me give 4 to kinetic energy. Again, that's arbitrary. Right? Again, moving parts of the machine, friction is creating heat, so we have thermal energy. I'll just put 1, probably more, but I can't go over 6 because I chose 6 over here. And usually they're quite noisy, so it adds sound. And I only have room for 1 more dot. There you go. Okay, I mean, some drills also have a light on them, so you can see better. So you could have had, if you want to put in radiant energy, you can. If I add a dot here, that just means I need to make sure I add a dot there as well. Okay. So what I want you to do is continue to try these. So on our last page, question number 3 is the same thing. You're going to draw these energy store diagrams to show how energy is transferred from one thing to another. So in this case, okay, we have a paved driveway becomes hot on a clear sunny day. Okay, so energy from the sun is radiant. It hits the pavement. Okay, I'll let you guys finish.